Right guys, so today we're going to do the 2010 higher level even sort road geometry question, and in the question it says the accompanying map shows ground contours at 5 meter vertical intervals, and we can see that our scale is 1:1000. So ABC is the centre line of a proposed roadway, ABC. The section of the roadway between A and B is level at an altitude of 60 meters. So straight away, a bit of information they're giving us on the sheet. We can look at that as key information. So straight away at A I'm going to write in there 60, and at B I'm also going to write in 60. And after that it says the section from B to C has a gradient of 1:30 rising. Using side slopes of 1:1.5 for cuts and 1:2 for embankments or fills, complete the earthworks necessary to accommodate the roadway on its northern side. Note, the earthworks on the southern side of the roadway have already been completed for you. So before we even get on to section B here, we're just going to focus on section A. So straight away there, as I said, A to B, altitudes of 60 and 60. It does not tell us an altitude for point C, and what we're going to have to use in a while is the gradient that from B to C, which is from B here to C here, it has a gradient of 1:30 rising, and we'll work out that bit in a while. So what we'd always start with is probably the easiest part of this question is where the roadway is level, which is from A to B, and it is at a height of 60 meters. So looking at our contours, which are 5 meter vertical intervals, what we have to do is we kind of have to work out our magic number. So the magic number, if we're working with the difference is 50 to 55 to 60, it's 5 meters in between them, and our scale is 1:1000. Straight away we know our magic number is 5. So straight away just put in a little 5 in there. Now what I'm actually going to work out next is, and I'd advise anyone who's doing these questions, is always to set up a little guide up here or in some little space that you have. In the question here they've given us a little space here, but on the day of your exam you might get just a rough sheet and put it in somewhere else on a rough sheet, so you kind of have a little map to follow. It's kind of like a little key or a legend. So for our fill triangle or embankments, I'm going to put in fill here, and I'm going to make a little triangle. And then for our cut here, and another triangle. Right, and it says here for our fill one we have a ratio of 1:2. So that means for every 1 meter drop it's moving out 2 meters. So basically if I was to drop down 10 meters it would go out 10 times 2 is 20. If I was to drop out down 1 meter it goes down 2. If I was to drop down 5 meters, it goes down 10, and so on. You just multiply whatever the drop is by the number that it's with. So for cuts, then, we have 1:1.5. So every 1 meter down, it's going 1.5 meters out. So if I was to drop 5 meters down, 5 times 1.5 will be 7.5. And our magic number here is 5. So for every fill line we're going to use 5 times 2 is 10. And for every cut line we're going to do, it's 5 times 1.5, which is 7.5. Straight away, that should be the first thing you always start at the beginning of your question. Now, from here, so A to B is the first part of the roadway I'm actually going to work on. I'm going to look at the contours. So at this contour here, it is reading 55, 60. So that's actually a point on the road there straight away. 60 is touching the road right there. And is there any other 60? Yes, there is, at a point right here. So I know there are two definite points I have where our land is going to hit the roadway. Now, 55, it's going lower here. At this point, it's 65. I think this one's, 60, 65, 70, 75, 80. Okay, so at this section we can see that the roadway is at 60, but the land around it is greater. So if the land around it is greater, what are we going to do? We are going to cut, which is at a ratio of, a measurement of 7.5 out. So that means from the side of the road, I'm going to measure out in increments of 7.5, 7.5, 7.5, and so on, until basically I hit the height of 80. And remember, the side of the road is starting at 60. So, using our sliding set squares here, and I'm going to use this pencil here, I'm going to measure out from the side of the road, I'm going to measure out 7.5s. So, 7.5, 15, so that'll be 65, 70, 7.5, 7.5. That's probably as much as I need for now. And using our sliding set squares, I'm going to set up a little grid. Now, so if this one here is at 60, then this guy here is going to be at 65. For cuts, it's always going to rise away from the road because you're rising with the land. This is going to be at 70, and I can see the highest it's going to go up to is 80. So there's my 75, and there is my 80. I actually didn't need the top one, so I'll rub it out just to keep it neat and tidy. It's gone. Now, from there we can see 60. So at the next one then, which is going to be at the 65, which is along this line, here, point there. This is going to be at 70. This is going to be at 75. This is going to be at 80. Got another one here at 80, and then it's going to start dropping back down. 75, 70, 65, 60. So I can actually start to draw in that portion of the roadway where it has been cut. And that's all cut away from the land. Just go over that in heavy now, because I know that is a finished part of it. Okay, now at this portion of the roadway, at this contour was at 60 meters. Here this contour is actually at 55, 50, 45, 40. So at this portion of the roadway we can assume that the land is actually lower. And when the land is actually lower, what that means is we actually have to fill it. And for our fill measurements we had, our magic number was 5, 5 times 2 was 10. So from here I'm actually going to start measuring out in, instead of 7.5s, I'm going to start measuring out in 10s. And this time they'll actually go down from the road. So, from the side of the road, I'm going to measure out as best I can 10, 20, 30. I can see 1, 2, 3, 4. Yeah, I think 3 will do. So, same concept, only this time we are doing fills. And at this portion of the roadway, I will be doing fills. So straight away there, if that was 60 here, 60, I always just put these in as a guide. Then this one's going to be 55, this guy is going to be at 50, this guy is going to be at 45. And I don't think I'm actually going to need a 40. So straight away, we'll see where the 55 cuts. 55 cuts right here. Then the 50 is going to cut on this one. And then the 45 is going to cut on this one. And we can see 40 would have been up here, so our 40 would have gone up here somewhere, but we can't see it at the moment. So straight away there then, I'm going to once again draw in my contours of where the land is cutting away. I'm going to continue it on up there, just guessing roughly. And once I've that done, I'm going to heavy it in. There we go. Now, very important, what I would also do at this stage is I would actually start putting in my tadpoles, because I want this section out of the way. It's done because I want to get over here in a minute. Now, when it is cut, we have to wonder, is our tadpole rolling with the little ball, is he rolling away from the road or is he rolling towards the road? And we know the land around here is higher, so the ball, if we put it on the top of the hill, will roll in towards the road. So what I'm going to do there is put a little tadpole, little squiggle down, tadpole, squiggle down, and he's going to roll into the road. However, the road here is actually higher than the land down here, so at this point it's a tadpole, with a tadpole with the ball rolling down the road. Very simple. Nice. Right guys, so second part of part A. With this part done over here where we just had a simple, in this section cut, in this section here fill. Now we're on to the next part of the question. And if you can remember at the very start of the question it said the road was rising from B to C in a ratio of 1:30. That means for every 1 meter up that we go in elevation or in height or in altitude, we are going to travel a distance of 30 meters on the road. So what we have to work out is at some point on this road, and now a scale here, it won't give us an exact point where C is because we don't know what that measurement is. So we're going to have to work out a measurement using that kind of gradient. So in the space here, what I would always do is I would work out just what that would be. So when 1 in 30 rising, using a little scale here, so 1 in 30, for every 1 meter I'm going to go 30, probably something like that. So what that means is, at this point in the road, which is where B is, we know he's at a height of 60, and it's after jumping up 1 meter here. So that means that's technically at 61 now, but we're after moving 30 along the road from here to here. So that means at this point we're after travelling 30 meters, and at 30 meters down the road we're now at an elevation of 61 meters. But what we want to do is we want a nice round number. So we could either go up to 10. So if we went up 10, it would actually be travelling 300 meters, because 10 up, 10 times 30 is 300. But if we look at our sheet, I don't think it's going to go to 300 from B. No, it goes out to 22, roughly. 22, 220. So I'm going to do half of 300, which is going to be 150. So if I multiply 30 by 5, okay, it's going to go up 5 meters here. So that means to go up 5 meters, I'm going to travel a distance of 150. So times 5 is 150, and that means we're going to go up 5 meters in height. So what I will do at that point then is I'm going to, from B, measure out a distance of 150. Right there. And at that point on the road, I can take it that I am now at an elevation of 60 plus 5. I am now at an elevation of 65. Just put that in there. 65. So from here now, what we have to do is we're going to basically put in a little cone in this section or this section here. We just have to work it out. And it all depends on the land around it and whether we are going to fill or cut. So let's turn that on there. Now, looking at the land around it, we can see the contour here is at 60, 55, 50. This one's at 50, 55, 55, 50, 45, 45, 50, and so on, until we get over here to 55 and back to 60. So if the road is here is at 60 and the land is here, or this point here is at 65, continuing on to C, we know it's we can see it's either still going to be 65 if it leveled off, or it's still going to be rising, and imagine it's going to be about 67 or maybe 68 meters at this point. Therefore, all the land around it at this moment in time is actually lower than it. So if the land is lower than the road, that means we are going to be filling. And our measurements for fill are going to always be 10s. However, what we need to do is we have to create this little cone, which is going to give us the description of the road at this height. So when we're filling, we are always going to do the cone at the higher part of the road. So we have to work out the measurement. So 65 takes 60 is 5, and 5 multiplied by our fill ratio, which is 2, is 10. So we are actually going to create a cone that is going to be in radius of 10 millimeters. 65, I'm going to just measure up very quickly a ratio of 10, or measurement of 10, sorry. There we go. And from B, should have actually specified this. It's from the side of the road. And if you imagine B was to come over here, this is very important, because it wasn't at this point here. It's actually where I would extend this up and bring the road out from this point. from there I'm going to create a tangent. And that tangent has a height of 60. Okay, now what we are going to do, and we know from this point, is the land around it was lower, so we are actually going to do, if that's 60, then my measurement out would be 55, 50, 45, and I think the lowest it goes down to is 45, and then inwards would be 65 and so on, but I don't see anyone here that is 65, so I don't have to worry about that. So, using that as my guide, what I'm now going to do is just create a little line so I can get accurate measurements from. Let's rotate it up a little bit, and from the center I'm going to use this as my guide. I'm going to measure out in increments of 10. I think I might need only about 3 of them, so 10, 20, 30, and sliding set squares after that. So this one's going to be at 55. I think 55 was all the way over here, yeah. I'll bring that the whole way. 50 goes over here. I just realized the 55 extends out to this one. 60 goes out as far as this one. And 55, 50, 45. There we go. So if that was 60, this one is going to be 55, this one's going to be at 50, this one's going to be at 45. Now I can plot my points. So to plot my points, we have 60 here. I have and then the final one was at 60, which would have been in here. Just extend it on, just to be safe. Make sure I'm doing it accurately. There. Now, at this point, I have all my points. I'm going to actually put in my graph, or sorry, my contour line of where it will be filled up. This is all in lightly at this moment in time. Okay, now the problem is at this point here we actually have to realize whether or not where it's actually going to intersect. So it is. So we actually have to find kind of where the plane of where this actual cut part here is going to intersect with this fill part over here, and it's going to join into the corner of the road. So what I actually should have done when I first started off is I should have done the extra part of the curve in here. So if you remember, this was 60, this was 65, that's going to be 55. I'll actually have to use my, just realizing, it is going to be 55 here, and that is lower than the road, and when it's lower than the road I'm going to have to use my fill ratio. So it's actually this measurement up here is what I'm actually going to use. So I'm going to extend that down parallel to the side of the road. And I will have to use the 55. And it's going to come into there, like that. And that will give me this point right here. And what you can actually see is from this point here, it would have joined over there like that. And we can see that they intersect right here at this point. That intersection point is very important because that is the point where when we were filling the land here in relation to the fill and the cut inside in this section, it's where they cross each other. And where they cross, that's going to bring a point at the corner of the road right there. That means then I can heavy in this point and this bit here. Just the last part of that part A, I have to put in my tadpoles. So if we can remember, at this point of the road we were filling, and when we were filling, that means that the road is higher than the land around it, so all the little tadpoles are going to have little balls that are rolling away from the road. Put on one more here, maybe one more there. Okay guys, so the last part of this question is part B. On the map it says D, E and F are outcrop points on the top surface of the stratum of ore. The line from E to G is the strike line for the stratum and has been constructed as shown. Determine the dip of the stratum. And then it says a vertical borehole at F reveals a vertical depth of the stratum to be 25 meters. Determine the actual thickness of the stratum. Okay. So there's a bit of information we can actually take from that. And it says D, E and F are the outcrop points of a layer of stratum. And it's also telling us that this surface here is the top surface of that stratum. And we know the top surface of the stratum means that that surface there is the head wall. So that's the top of the head wall, which is where it's revealing the ore, be it the gold, the coal or whatever material or mineral we're looking for. So then it says the line from E to G is the strike line. So the line from E to G is the strike line. Now we always know in plan that that line there, because we're looking at the plan view of it here, this is the true length. So true length strike. Okay, that's the true length of our strike. And what I'm actually going to do is I'm just going to bring you up to a little recap that we did in class, and I'm going to bring you back to this. Now, just zoom in there, zoom out a little touch. Okay, here we have two planes. I have in my elevation up here above the XY line, I have a plane surface A, B, C. And I have the same surface, but it's obviously got a different orientation of it. And this is what A, B, C looks like when we see it as the bird's eye view in plan. So A, B down here, C here. And what we want to always get is we want to find the dip of that surface, or the inclination of that layer of material in relation to the mountain, okay, and what angle that is in relation to, say, how you stand. If it's 20 degrees at an angle, 30 degrees, whatever it is, that dip angle, okay. But we always have to get the strike before we get the dip. And how we locate the strike was, in the elevation we always did a level line from the middle point, A, B or C. So in this case the middle one of these 3 points is A. Level line across to where it intersects the line BC from A. And from there we dropped it down to where it intersected where it was BC down here, and we joined it to A. And what we actually got then was we got this line here, which is actually the true length of our strike. Because the reason we know it's a true length is any line that is parallel in one view, okay, so the line here A is parallel with the XY line, which is the principal plane. That means in the opposite view it has to be a true length. Therefore, same thing, if the line here down here was parallel with the XY line from A, if I went across and hit up here, and up here it wasn't parallel, but because it was parallel in the plan it would be parallel, or would be true length in the elevation, or vice versa. So now we have the true length of the strike anyway down here. And what we always do then is we want to see that strike. If we look out along it, we'll see it as a point view. And we see that point view when we look down along it right here. If you imagine it was going into our page, straight like that, straight into the page. Now, what we did was we projected out, so we looked out along the strike, parallel. So we looked out parallel from along A, C and B down here, and we set up an X1, Y1 perpendicular, like that. And after setting it up perpendicular, what we did was we located our points for C, for A and for B. So to find C, I took my measurement from the XY line up to C, which is that height there, which is the same as that. Same for A, took that height there, which is the same as this, and then for B the exact same here and here. And what we end up getting is a level line, okay, and they should all join through the points, join through each other. And what that reveals to us is the dip of our stratum, or the level, or the angle of that ore material, which is the head wall in this case. And that dip there is the angle, and we can see it inside in here. And all I did was I did a parallel line with the x1, y1, and just to reveal the angle rather than extending it down here. It's the same angle. But just we're going to use that information to help us out on this question here. So, getting back to that, we know that this is the true length of our strike. And what did we do in the last part where I just showed you there? When we looked at the true length of the strike, we looked out along it. So, straight away we are going to look out along it because we're trying to find the dip angle. So, looking out along it there, I look out along it, do the same from point D, and do the same from point F. And what I want to then set up is an x1, y1. X1, y1. Now, at this point, you might ask yourself, well, how, if I did an x1, y1, how am I going to determine the heights? And we can determine the heights because we can actually say the x1, y1 is at a certain altitude, and after that we can actually measure up. Because we know D is on the 55, so I'll just write that in there. For D, it's on the 55 contour. F is on the 80, and E is on the 65. So 55, 80, 65. So what I could actually do there to work out the dip if I wanted is I could say x1, y1 was at 50. But in this case I'm going to keep it a little bit neater, so I'm actually going to go out to 45. And what that means is, if that's at 45, and I'm measuring up in 5 meters here, because that is the spacing for my contours, so this then would be 50, 55, 60, 65, 70. So 50, 55, 60, 65, 70, 75, 80. And at any of those points, just to give me a guide, that one there is 50, 55, 60, 65, 70, 75, 80. And what I can do is I can locate my points. So, sliding set squares, just to give me an idea, because I have my guides. So this one here is at 50. I know my first one's at 55, which is where D is. So right there is point D. Then E, which is over here, is at 65. 55, 60, 65. There's my 65. And then the last one, 65, 70, 75, 80, going out to this guy. He's at 80, which is right here. So, I have located point F, which I'm now going to call F1. Located point E, which now I'm now going to call E1. And I have located point D, which I'm now going to call D1. And if I am correct in my measurements, they should all join in a level line. And as I can see, yes they do. And what I've actually found there, I will extend it out. And I will extend out my x1, y1. What I've actually found there, let's put it in neat and tidy, is my dip. That angle within there is my dip angle. Little symbol there for dip. If you want, you can write it in. I'll actually just go back over this. True length strike. Always tell the examiner what you're doing. So there's the true length of my strike, there's my dip, that's the first part of the question. I could measure that if I wanted, there's no need to. Now we get on to the last part of the question, and it says, a vertical borehole at F reveals a vertical depth of the stratum to be 25 meters. A vertical borehole at F reveals the vertical depth of the stratum to be determine the actual thickness of the stratum. So what they're actually saying there is, from F, a vertical borehole went straight down vertically. Okay, so it's going straight down. So from F, if you imagine we're up here now and we're looking down, so from F we're going to measure straight down, and it's gone down 25 meters. So from F, I'm actually just going to measure down 25 meters. What they're really testing you here is just on your understanding. And at 25 meters, which would be 25 millimeters. And at that point there, it says it reveals, a vertical depth of the stratum to be 25 meters. Okay, so that means that's the thickness. Determine the actual thickness. So from there, if that we know this one was our head wall, we now also have measured down 25 meters there, that distance, and that point there is going to reveal the bottom surface of our stratum, which is now, if we have the head wall, that is now going to be our footwall. And we always know the difference in, the head wall and the footwall are always going to be parallel. So there we go. That there is now our footwall. And perpendicular between the two of them is my thickness. So that there is my thickness, which is usually signified or identified with the letter T. I'm just going to write in thickness. There we go. Question complete.